Hi there!
Who, me?
No, not you. You! You've probably always imagined that because of the gravitational pull of the moon, there is only produced one tide per day. But you were terribly mistaken.
That's right, because there are in fact 2 high tides and 2 low tides every day.
I'm going to use Newtonian gravity to explain the differential pull explanation. We're going to imagine that first of all, the Earth is all covered in ocean. Second of all, that we can turn off the sun. And lastly, that we can turn off the Earth's gravity. So I've divided the Earth into 3 points. Point A, center of the Earth, and point B. And they are along the Earth-Moon line. So I'm going to turn off the Earth's gravity. Well, because we just turned off the Earth's gravity, and because of the gravitational pull of the moon, and because block A is 6,400 kilometers closer to the moon than the Earth's center, it will accelerate towards the moon more than the Earth's center will, and the Earth's center will accelerate towards the moon more than block B will. So at point A, the water will be lifted from the Earth, and at point B, the Earth will be lifted from the water. So now it looks like the 2 blocks have separated from the Earth, and this creates an outward force, and that is also what we call the tidal force. But the tidal force is in fact fake. So I just explained that the tidal force is what pushes the oceans to the side, and that can for instance be compared to sitting in a car that takes a turn at speed, and because of that you're being pressed to the outside of the car. Back to the Earth, it would mean that the outward force should make all objects accelerate off the surface, even though that they don't have the same mass. But remember, the Earth is not inertial. So the objects that are accelerating relative to the Earth's surface aren't being pushed out. This force along the Earth-Moon line is fake, and therefore the Earth isn't being stretched out. So if it was being stretched out, it would mean that sand or me and you should experience tides, which we don't. So there must be another explanation for this phenomenon.
So, to understand this, we need to look at the tidal acceleration of places that are not on the Earth-Moon line. So, for instance, look at this drawing. Point A is being pulled towards the moon, while the whole Earth also is being pulled towards the moon. And so, relative to the Earth's surface, the tidal acceleration of point A is inward, or in other words, down. In fact, if we look at the tidal acceleration of other places on Earth, they would look like this. So, the tidal forces do in fact only act like anti-gravity when you are on the Earth-Moon line, and not when you are, for instance, at point A. And because these places are mostly tangent to the, to the Earth-Moon line, the water is being pulled to the sides. So what all this means is that the Earth is in fact not being stretched and is not being lifted, but is in fact being squeezed towards the Earth-Moon line. And this means that the moon is actually turning the entire ocean into this huge pump the size of an entire planet. And this can be compared to the way that pimples bulge up in the middle when you squeeze them from the sides. So now that we have explained how the tides of the ocean can occur, we can begin to look at why we don't see any tides in lakes. Now, there is a very simple explanation for this, which is that the lakes simply don't have enough area for the small pushes to build up enough pressure to actually change the water level. Now, very big lakes can in fact create very tiny tides, but they just aren't noticeable because, for instance, the wind and boats creates much bigger waves than the tides. In fact, everything containing a body of liquid produces microscopic tides. This includes your cup of coffee in the morning, and in fact also the human body, which mainly consists of water. Everything we just explained is of course simplified. The only thing left to mention is that the sun in fact also has an impact on the tides. The sun also creates 2 bulges, but with an effect only half as strong as that of the moon. The sun's effect can be seen at springtime with the large spring tides, and these occur when the sun and the moon are lined up.